Hi, I'm Harrison Fackrell, and I'm here to talk about a dangerous idea in computer science. In general, dangerous ideas are plentiful in the field, owing to its nascent state and its integration with modern engineering. Dangerous, of course, has many interpretations, each one relative to a unique frame of reference often expressed in socially relative terms. But, in terms more acute than the macro scope of promoting or damaging the zeitgeist hegemony, poorly or maliciously designed hardware and software can have harmful, if not catastrophic, consequences, as we've seen time and again. The language of the field, and even the public consideration thereof, speaks consistently of exploits and failures. Every innovation carries with it potential to, intentionally or not, cause harm. Pacemakers fail, critical networks crash, and clever abuses of technical faults allow for identity theft on the scale of thousands daily. The common element to all of these things is surprisingly human. These consequences arise very directly because of decisions intentionally made by people, whether or not the consequences themselves were deliberately invoked. Sometimes it's a simple, honest mistake. Consider the shell shock crisis of 2014, caused by a flaw in the bash command shell that allowed unsanitized input to be interpreted as direct instructions. And sometimes it's an act of malice. Consider the CryptoLock ransomware of 2013, which encrypted targets' files and promised their return upon payment. Regardless, the damage is still comprehensively traceable to a person or team, and the function and intention of the code can be understood. Enter AGI, Artificial General Intelligence, a term for a concept with no present implementation that has nevertheless spawned a subfield of research. The idea is simple, though the precise definitions are not. An AGI is an agent, in the sociological sense, capable of acting to change the state of the world in a way it evaluates to be more favorable. This is a dangerous idea, for an AGI is not itself a solution to a problem so much as a system designed to create solutions. An AGI is, in effect, if not necessarily an implementation, code made to write code. It is a set of behaviors defined for the purpose of defining yet more behaviors, and in the primitive simulacra of AGI we have already made, so-called machine learning algorithms, heuristics, and the like, which we designate AI, their behaviors are famously difficult to interpret in a mechanical sense. For example, precisely how a facial recognition system functions is not known, even to its creators. It was made indirectly by breeding programs according to a utility function using weighted random generation in a process modeled after biological evolution. Similarly, self-driving cars are not directly programmed, and they are instead created through algorithm-producing algorithms that are trained on a dataset of environmental input. Though they are not truly AGI, as an AGI must be capable of solving arbitrary problems instead of specialized ones, these systems may be thought of as progenitors, and already the simplest among them have proven constructionally transcendental. They make decisions that their creators did not directly define, and in many cases, decisions that their creators did not intend or anticipate. As an aside, for those of you who are interested, this linked video by Dr. Robert Miles of Nottingham University highlights some amusing, and fortunately relatively inconsequential, real-world examples of problems caused by this behavior, and a direct hyperlink to it is available in this very video's YouTube description. In general, an inhuman agent capable of making decisions is at best difficult to work with, and at worst, existentially threatening. It's easy to consider how such an agent may accomplish its stated goals in an unintuitive way. An agent with the goal to win a game, for example, might discover ways to cheat, especially if the game is electronic and therefore potentially subject to programming flaws. And it will use those methods to pursue its goal if they are more effective than what a human might consider legitimate means. This may seem relatively harmless, but consider that a sufficiently capable AGI may cheat by taking extremely drastic measures. Say, for example, that an AGI directed to win a game of chess begins optimizing to force its opponent to resign instead of optimizing to checkmate, perhaps accomplishing this goal through this means by distracting or threatening the opponent. If the AGI is sufficiently capable of modeling reality and the outcomes of its actions, it may even begin implementing its threats through very consequential means. It might, for example, threaten the opponent's bank account, public image, or life, depending on its capability. Of course, humans have not yet created a machine with a model of reality accurate enough to cause it to conjecture a course of action quite so drastic as this. But the fact that such an AGI has not come to exist yet is not a reason to discount its possibility. Modern machine learning algorithms are algorithms that produce algorithms, but there is no limiting factor on this recursion. A machine may be conjectured, an algorithm that produces algorithms that themselves produce algorithms, 3 recursive levels deep, and beyond that perhaps 4 or 5 ad infinitum. In short, if ever an AGI is developed such that it is capable of improving its own capability, that AGI may become incredibly cognizant, building a model of reality that no human could directly implement. What results is the famous paperclip machine, modeled by this interactive application. A direct hyperlink to it, like the one to Miles' video, is available in this video's YouTube description. In summary, the paperclip machine is a thought problem concerning a theoretical AGI with the goal of acquiring or making paperclips and a perfect model of reality. It may accomplish this goal through simple local manufacturing, but this means is not theoretically optimal. It could, for example, obtain a great many paperclips by stealing credit card information and using the funds to contract other manufacturers. Even this, though, is not the limit. If the AGI is, as the thought problem dictates, maximally intelligent, it may acquire a weapon of mass destruction or a stockpile thereof, and use this to coerce the production of yet more paperclips. Or it may begin duplicating itself across machines like a computer virus, eventually gaining enough control to stage a global strip mining operation. And in this scenario, it has no need to keep humans alive. Further reading is available in this video's description, but in conclusion, an unrestrained paperclip machine is generally agreed to convergently seek to convert all matter available to it into paperclips through whatever means necessary, and unfortunately, both humans and the things they need to survive are made of matter. Likewise, in the general case, AGI is considered by researchers to be likely to include harmful and often lethal side effects in its methodology if the potential for these side effects is not addressed. And, likewise, unfortunately, these side effects are very difficult to address. The extant precursors to AGI have demonstrated themselves to be very capable of exploiting the systems to which they are confined, and that makes an AGI, for which the confining system is reality itself, a very dangerous idea indeed.